Hello everyone, my name is Jorik. I'm visiting from Berlin, where with a small team of 5 I'm creating the software called vvvv, which is a visual programming environment. Out of curiosity, I would like, can I have a quick show of hands, who has heard of vvvv before? Okay, thank you. So my first introduction to visual programming was during my studies, when a professor came up to me and he gave me a big book that he said would be interesting to me, and he was right. It was the following book. I want to show you a picture of the book, so I'm loading the image here. It was this book. Does anyone remember this book? It was the Opcode Max user manual, like a big book. And he was right. I was immediately intrigued by the fact that this program would allow me to create, instruct the computer to do what I wanted to do by creating these abstract graphics. Max back then was Mac only, and I was a PC user. This was around 2000. And I was lucky to then discover that there is also the PC version of this, which looked even more brutalist. It's PD, of course. And I was really hooked to this, and I was playing with it a lot. I liked this brutalist style, and I immediately noticed a huge increase in productivity using visual programming over textual programming. Then I also found this. Just wanted to see if some remember this. And I was totally blown away by the fact that you can use serious software to make like weird things like this. And it dawned on me, yes, I have a lot of ideas about how a visual system should work and feel and look. And so I was doing my diploma thesis on implementing a visual programming environment, which became vvvv. Meanwhile, like fast forward a few years, vvvv is now a commercial software. And I want to show you briefly a video, a show reel of works that people do with it. So we had our first release in 2002, and from the beginning we concentrated very much on large-scale visual interactive installations. So while vvvv can also do audio, it is in no way comparable to what Max and PD can do with audio. We can play audio and route audio a little bit, but we don't do audio synthesis. So we do like visual graphics synthesis. So it's used around the world by artists, or also a lot of in corporate settings. This is where we make our money with. People use it for trade shows to create large-scale interactive rooms and presentations. And we come from Germany, so it's big in the auto industry, where a lot of car shows are made with it. People use it to control robots, and it's also used, this was for Lufthansa, where they wanted to have a visualization of all the flight paths of their whole flight database. And it's used in virtual reality. This is a work done recently by Marshmallow Laser Feast, a London-based company. It's a multi-user VR experience where people see each other in this virtual space to interact with each other. So this just to give you an idea of what people do with the software. And what I want to talk about now is more like I want to just briefly show you how it feels like to work with the software. So as I showed you, we had the first release in 2002, but over the years we became aware that we are kind of limited with the software that we built, and we added, because data flow visual programming has its limits in what you can express and in complexity of a program, and the programs got more demanding and complex. So we added, already 10 years ago, we added some scripting capabilities. So you might be aware, like with JavaScript, where you could script something in vvvv, it was C# script that would allow people, if they are stuck with visual programming, they could add to their programming with C# scripts. And now we were not really satisfied with that, because it went away from visual programming, and we wanted to take all the features that we have in text programming and bring them into visual programming. So we started again from scratch. That was about 6 years ago, and what I present here today is this new version, and I want to concentrate on 4 aspects of the software. I want to show you how we are using loops in a visual way. I want to show you how we do multithreading in a visual way. Object-oriented patching is a big thing that allows us to create things like particle systems without writing any text. We just visually create dynamic particle systems. And I want to, if time permits, talk a bit about extensibility. So let's see how far we get. I have prepared a little scene here already. First I want to talk about loops, so I will have to set the scene for that a bit. I am using a sphere here that I put in the scene. I will scale it a bit to make it smaller, because there will soon be many spheres. I will move it a bit up. So this is one sphere in a world where there is already a light that I can move around. Now I want to interact with the sphere, like as I hit it with the mouse, it should play a note. So I would use the mouse ray and say, when the sphere, when the ray intersects the sphere, which I still have to create. I'm creating a sphere from a position, so I'm taking the position of the sphere, and I'm also applying a radius, which will be, if I take double the radius, that's the scaling. So now I have a sphere here, and as I intersect with the mouse, it should actually, I forgot to connect it here. So now as I intersect with the mouse, you see the intersection returns true here, and I can use MIDI out just to create a MIDI note out. As the intersection happens, I want to play a note. Okay, so I promised I wanted to talk about loops. So far I've only set this scene where I can interact with one sphere. And the question is, how can I now interact with many spheres? The way we do it is I can simply select a surround, a bunch of nodes, and say I want to surround them with a for each loop. Now I have to reconnect the sphere here, because now I suddenly have many spheres. So I first have to collect them together on a group spectral node. And I don't see any spheres yet because I don't provide any positions yet for the spheres. So I will add a random spread here, which is just a node that generates a random, a number of random positions. Oh, sorry, that was the wrong pin here. So now, as you see, and I can change the arrangement of the spheres, get a different random spread. As you see, I've simply surrounded the spheres, this program with a loop, and now the interaction works on all the spheres. In a loop, someone would expect there is an index that I can use to create different node numbers now. So the index is just an integer that would count up for each iteration. So like this, I can easily have a different node on each sphere. And just to also visualize this quickly, I can use a material here which will get a color. So I want a blue, I want it to be blue as the intersection happens so that I can also see what's happening. Okay, so the point is that my program stays very simple and I only surround it with a loop, and I can easily say these should be a lot of spheres without changing the program too much. This becomes even more interesting if you get an understanding of that. Obviously, loops can be in loops and in loops and in loops. No, this is not a one-dimensional thing. So I can add another loop here now, surround this with another for each. Means I have to use another group spectral down here. Again, I need to drive the loop with something, so I'm using another random spread 3D, let's say, which I connect here and then here. And now I have, as you would expect, we should have three. Let's see. It's somehow not behaving as I expected. Is anyone spotting the problem? I should have three clouds now, each around the center. Ah, they are down here. So if I create more of them, you see I have, yeah. I think this explains now. And they're all still interacting independently. I can animate them, of course. So just so much regarding the idea of loops in vvvv. Next, I wanted to talk about multithreading. For this, I will first create a little thing that runs very slow, because I want you then to see how I can offload it to another thread. So this should create a render window here where I see the camera. We have a YOLO, you might have heard of that, YOLO detector thing here, which I have to configure briefly with the config file and the weights and the names. YOLO is an image detection algorithm that will detect certain things in an image, and it will tell me what it is. It will tell me what it detects in this in the image. So the first thing it should detect is a person, and you see it's very slow because it's running on the CPU. It's a machine learning process, and it should also typically it would detect there is a phone, and here in the labels you say, I'm not sure if you can see it, it says cell phone of the person is detected. Okay, this just to show we have a very slow process going on here, and the camera is very shaky because the whole system is now on high demand. So actually I want but this machine has multiple cores, and I want the YOLO detection to run on a separate core. So what I can do is I can send this chain of computation to a background thread. And to do so, I need to use two nodes here. I need to use something that's called an observable and then send it to the background. Now this whole thing has moved to pushing the images downstream, and for each image that is being pushed, I can now evaluate the YOLO detection in the background. And now, since this is on a separate thread, I have to sync back to the main thread to get the result, and I'm using the hold latest node for this. So after this is done, it will report the result. And you see now the difference is that the camera is still moving fast, and only the computation of the rectangles is slow. So it's working, but my main program is still running, right? And this is important when you do installations like this with a lot of different input devices and output devices that run on different speeds. We still want to be able to combine this in one environment and don't have to break it up on different machines or different softwares on the same machine, which makes everything just more complicated. So this was a demo on multithreading. I have here just another brief thing of the same idea. We have this region which is called an async task, where I'm computing a very heavy random number. As you can see here, I'm just computing a random number between 0 and 1 something. And there is a thread sleep of 1 second. And as I trigger this, down here, after 1 second of blocking the core, the number shows up. But you see, while I do this, the program, the main program is still running. The camera is still fluid. So that's the point here. The last, next one would be object-oriented patching. How can I get a brief, give you a brief idea of object-oriented patching? It's a rather complex topic, as you might know if you're familiar with the idea. So I'm trying my best. I've prepared a particle system. Particle system, here it is. Something is now blocking. Oh, it got it. The particle system takes the position of the mouse with a ray to mouse node. And it just returns an entity which I can draw. So I can just add that here. And we see we now have these particles, and I will turn this off. We have these particles following the mouse. So, and you see building something like this in a pure data flow environment used to be hard. Let's have a look at how this example looks in vvvv now. So the heart of the operation is really what you see here. We have two pads that hold the particles. They are holding a spread of particles. So we have a class somewhere, a class of particles that we define, and then we can instantiate them and kill them off after a while. So what is happening here is as this add input is true, particles are being added, and it's true now by default. So in every frame using this if region, since the condition is always true, the particles are always added. And then it says for each particle in the spread, in the list of particles, we just call the update function on the particle, which will move the particle and scale it down. And actually the scaling happens here. But it advances a lifetime of the particle, so that each particle has an age. And it says here, I'm only keeping particles whose age is less than a second. If it's more than a second, then the particle is just not delivered out in the spread again. And down here, this part is only for drawing the particles. So really the particle system management is just happening here. And I want to give you a brief look at the particle implementation itself. So we can enter the particle, and this is the class called particle, which has a property called position. And it has a stopwatch inside, which is just whenever the particle is born, a stopwatch is starting to count the time. And it's just returning the time so that outside someone can say, okay, if you're older than 1 second, I kill you. Just to show you briefly how I can easily modify this class now, is you see the behavior of the particle system is now like a very simple snake behavior. As I modify the speed now of the position of each particle, you see it recompiles, and now I'm not sure if you see it. Maybe I should increase the, yeah, I think you should see the behavior is now not snake-like, but the particles are like dissolving in all directions. So this just to show you how we can modify the class of which we can make any number of instances. We can just modify it in real time while the program is running, and it will be recompiled all the time under the hood and just show the new behavior of the particle. So I'm not sure if this is clear in such a short presentation, but I want to move on to the last point, which is extensibility. When you have an environment like this, you don't want people who use it to be stuck when they are missing a functionality. So it's very important that anyone can extend the functionality of the program easily. vvvvs are built on .NET, if that says something to someone, and .NET has a package manager. I'm sure people are familiar with the NPM package managing from JavaScript, or there are other package managers. .NET has a NuGet package manager with more than 100,000 packages that are being contributed. And what I want to show you is that in vvvv you can simply use all of those packages without the need of writing a plugin for them or writing a wrapper around them. You can simply use them. And the way this works at the moment, you need to use the command line and say NuGet install, and then put the name of the package that you found that you want to use. String extensions in this case. I press enter, it downloads the package. I've actually done this before to make sure the internet connection is not, but it worked again. So what we can now do is, now that the package is available on my machine, I can simply go here to the dependencies, .NET Nuggets, and I'm looking for string extensions. That's the one I just installed. I activate it, and now it's just part of my available nodes here. I can browse down here. It's in the string category, extensions, and now there are a couple of simple string operations. Keep only numbers would be the node that I just want to test quickly. So I have a string that has numbers and characters, and you see the result is that. Just to demonstrate, I'm using any of these 100,000 libraries on the internet to extend my program, and I didn't even have to restart the program while I did load this new functionality. So That concludes my demonstration. I would like you to try this yourself. If you go to this website, visualprogramming.net, you can download it. It's free for non-commercial use. It's free for evaluation. There are no limits, no need to register. We just trust you to, when you use it in a commercial environment, that you buy the license from our website. That's it. Thank you very much.